Now let's see this one, relative addressing mode. So the name itself says that the addressing mode is relative to some point, right? So why is it useful? Where it is useful is, I'll just take an example and explain you. Let us say we are having program, a program is loaded in the memory like this, and assume that this each column represents this, each row that I'm drawing, it represents a word, and the instruction is loaded there. And say the address here is 300, it is 301, it is 302, it is 303, so on. Let's say it is 320 somewhere, and 321, something like this. Now say we have an address here, see program is starting somewhere here, say we have an instruction here which is a branch instruction. Okay, branch instruction, let me write it as BR without worrying about exactly how it is implemented. Let's say it is a kind of jump, which means from here the control should move to, let's say, 321. From here I have to go to 321, right? Now if I directly provide this particular instruction and if I put the address directly here, that is called as direct addressing. But what is the problem of direct addressing? The instruction size is going to be bigger because of the address which is present here. Now if I want to decrease this instruction, what I can say is, relative to this particular instruction, how far is the branching? Is it a displacement which is positive, or if I want to branch some words backwards, something backwards, then the displacement is going to be negative. So relative to this instruction where I wanted to branch, if I want to provide that, then a special type of instruction mode is provided, which is called as relative addressing. So what is relative addressing is, we just say with respect to the program counter how many words we want to descend or how many words we want to go up in order to get the next instruction or in order to obtain the effective address. So what does this mean is, effective address is computed like this, is equal to PC plus the address part of the instruction. Got it? So instead of putting 321, what I'll put is how many words I want to go down. That one I am going to put there, right? So in this case there is a small difference here, there is a slight difference here. So since we are going to use PC, the problem with PC is, so how it will work later when I show you about the design of the computer, this CPU, then you will understand how PC will work exactly. But here, just to understand this concept, I want to tell you few things. Now how does PC work is, PC is nothing but a program counter, right? So which will contain the address of the next instruction that has to be executed. Let us say we have fetched the instruction 300, then PC was initially 300. After fetching it immediately, it will get incremented to 301, which means even when this instruction is not yet executed, immediately after fetching it, the address is going to be incremented by 1. Therefore the program counter is going to show the next instruction number even when the previous instruction is getting executed. That is how it is going to be built. Why is it built like that? We shall see it later. So try to understand it. Whenever program counter was 300, the instruction at 300 is being fetched. But then even before executing it, even before decoding it, the program counter is going to be incremented to 301. Therefore, while executing the instruction which is present at 300, program counter will actually contain the number 301. Therefore, if you want to go to 321, you should not add 21 to this, you should add 20 to this, which means branch 20 will actually take us to the address 321 in case if you are using relative addressing mode. Got it? So what is it exactly? Try to understand this one. You are at 300, you have to go to 321. What is the difference? 21. But then you are not supposed to write 21 there, because by the time we are executing this 300 instruction at 300, your PC is actually pointing to 301. That is why already your PC is pointing to 301, and then what should be the address you should provide so that you will jump to the address 321. It is nothing but 21, isn't it? The address that you should provide in the instruction is nothing but 20. If you put it there, then we are going to go here, right? So I'll just ask you one more question, just try to answer it. Let us say we are using this relative mode. In this relative mode, if we are executing an instruction which is at address, let's say 300 itself, right? Then if it is relative mode and if it is branch minus 10, then where do you think you will land up, or what do you think will be the effective address? Then effective address, we know in relative mode, is equal to program counter plus the address given in the branch instruction, right? Now what about the program counter? Since we are executing the instruction at 300, the program counter must be pointing to 301, assuming that the instructions are taking up exactly one word, right? So in that case, the program counter is going to be incremented one by one. So in most of the cases it is true, right? So program counter is, unless they specify it, okay? So program counter is going to be 300 here, plus what about the this one, minus 10. Oh, program counter is going to be 301, and what about this, minus 10. Therefore effective address is 301 minus 10. Got it? It is not 300 minus 10. So that is the use of relative addressing mode. So what is relative addressing mode is, it is especially used whenever you have this branching instructions. So when is it going to be used is, whenever the branch has to happen to some few words relative to the present address, then we are going to use relative addressing mode. The main advantage is size of the instruction will be less compared to directly giving the direct address. Got it? Since we are not giving the entire address, we are just giving the displacement, very often this instruction tends to be of smaller size, right? And therefore loading the instruction is easy, decoding it is easy, and executing it is easy. Therefore we can decrease the number of bits required using this relative addressing mode. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.